We are still continuing on in Unit 2, where we are learning to graph all kinds of linear equations. In Chapter 3, Section 5, we will be extending what we know to parallel and perpendicular lines. Parallel lines are any two lines that do not intersect. It's not enough that they just don't intersect on your graph that you have in front of you, but that they will never intersect if they are extended forever. You can see three pictures here of sets of parallel lines. In the first picture, we have two parallel lines that run like train tracks. Even if we extended these lines out forever, they would never intersect. The reason why they never intersect is because they have the same slope. Since they have the same rise over run, they head in the exact same direction and never intersect. In our second picture, we have vertical lines. We need to describe parallel vertical lines a little different because their slope is undefined. So it's not enough just to say they have the same slope. So to be more specific, we will say that any two vertical lines are also parallel. In the last picture, you have two horizontal lines. For those, we don't need another rule because they have a slope of 0. They have the same slope, and so they are parallel. Taking a look at example 1, we are asked to figure out if the two lines that are given are parallel. Remember that either they have the same slope or they are vertical lines. That's the condition to be parallel. Let's check out the slope of these two lines. Our first line, y equals 3x minus 5, the slope, or m, is equal to 3. Let's call it m1 so that we can decipher between the two equations. The second equation is y equals negative 3x plus 2. The slope there, we'll call it m2, is negative 3. These two slopes are similar. They both have a 3, but they're not identical. So these two lines are not parallel. Let's look at part C. Our first line in part C is 8x plus 6y equals 36. To easily find this slope, let's solve the equation for y. We can subtract 8x from both sides to have 6y equals negative 8x plus 36. We can also divide both sides of the equation by 6 to get y equals negative 8 over 6x plus 36 over 6. We can simplify 8 over 6 by dividing both by 2. 2 goes into 8 4 times, 2 goes into 6 3 times. Also, 36 divided by 6 is 6. So our equation in slope-intercept form is y equals negative 4/3 x plus 6. Now we can easily tell that the slope of this line, we'll call it m1, is equal to negative 4/3. Let's take a look at our second equation. Our second equation is already given to us in slope-intercept form. So from this, we can tell that the slope of this line, m2, is equal to negative 4/3. Since our two slopes are identical, this means that the two lines are parallel. Let's take a look at example 2. In example 2, the instructions have changed. We're only given the equation of one line, and we are asked to find the slope of a line that is parallel to the given line. Since parallel lines have the same slope, we simply just need to find the slope of this line. Let's solve for y so that it's in slope-intercept form. We can subtract 2x from both sides to have negative 9y equals negative 2x plus 36. We can also divide both sides by negative 9. This leaves us with y equal to negative 2 over negative 9x plus 36 over negative 9. Simplifying negative 2 over negative 9, we know that two negatives make a positive, so this is positive 2/9 x. 9 goes into 36 4 times, so positive 6 divided by negative 9 is negative 4. Now that our equation is in slope-intercept form, we can easily see that the slope is equal to 2 over 9. And any line that is parallel to this line must have the same slope. Now let's switch to talking about perpendicular lines. Two lines are perpendicular if they intersect at exactly 90 degrees, or right angles. We can see this in our first picture here. Notice that these two lines go in the exact opposite directions, and so when they meet up, they meet at exactly 90 degrees and form 4 right angles. More specifically, two non-vertical lines are perpendicular if their slopes are negative reciprocals. I also like to refer to them as opposite reciprocals. What we mean by this is that their signs are opposite. One is positive and one is negative. And reciprocal means that one is the other flipped over. One slope is the reciprocal of the other with the opposite sign. Now let's take care of the case when we have a vertical line. Vertical lines have undefined slopes, so we can't refer to their slopes when deciding if they're perpendicular or not. So what we'll simply state is that a vertical line is perpendicular to a horizontal line. In our second picture, you can see that a vertical line and a horizontal line go in exact opposite directions and form 4 right angles. One way we can determine if two lines are perpendicular to one another is to find the product of their slopes. If the slope of one line is m1 and the slope of the other line is m2, they should have a product of -1. Think about this for just a second. If they have opposite signs, that means one of them is positive and one of them is negative. So the product necessarily needs to be negative. Also, if they are reciprocals, then the numerator of one will simplify with the denominator of the other, and vice versa, simplifying to be 1. So the product should be -1. Let's take a look at some examples. In example 3, we are given two lines and we need to decide if they are perpendicular. In part A, the first line is y equals x plus 5. The slope of this line is 1. We'll call it m1. That's the coefficient of the x term. The second line is y equals -x plus 2. The coefficient of the x term here is -1, so our slope, call it m2, is -1. We can do a quick check that m1 times m2, or 1 times -1, is equal to -1. So these two slopes are opposite reciprocals, and these two lines are necessarily perpendicular. In part B, we have two more lines. The first one is y equals 3/5x plus 6. The slope of that line, we'll call it m1, is equal to 3/5. Our second line, y equals 5/3x minus 3. Our slope here, m2, is equal to 5/3. Notice quickly that these are reciprocals of one another. We have 3/5 and 5/3. But when we check their product, notice that while everything simplifies to be 1, it's +1 instead of -1. That's because these two slopes are reciprocals, but they're not opposites. They're both positive. Let's go on to example 4. In example 4, the instructions are a little bit different. This time we're given one line and we are asked to find the slope of a line that's perpendicular to the given line. So we need to find the slope of the given line and then find the negative reciprocal or opposite reciprocal of that slope for a perpendicular line. Let's take a look at part B. In part B, we have 6x plus 8y equals -40. Let's solve for y so that we have it in slope-intercept form and can easily pull out the slope. Now we see that the slope, m1, is equal to -3/4. The question is, if a line is perpendicular to this line, what would its slope need to be? We need the opposite reciprocal. m1 is negative, so necessarily m2 needs to be positive. m1 is 3/4, so m2 needs to be 4/3. The opposite reciprocal of -3/4 is positive 4/3. If you prefer, another way to go about this would be to use the equation m1 times m2 equals -1. Substituting what we know for m1, we could solve this equation for m2 and we would still get 4/3. Let's move on to example 5. In example 5, we're given a series of pairs of lines. We need to figure out if they're parallel, perpendicular, or neither. Let's start with part C. The first line in part C is y equals 4x minus 1. So we know that m1 equals 4. The second line is 8x plus 2y equals 4. Let's solve this for y so we can easily find the slope. Subtracting 8x from both sides gives us 2y equals negative 8x plus 4. Dividing both sides by 2 gives us y equals negative 4x plus 2. You can verify the details in between those steps. So now we know that m2 is equal to negative 4. Let's compare our two slopes. These two slopes are certainly opposites, but they're not reciprocals, so they're definitely not perpendicular. They're also not exactly the same, so they're not parallel. In this case, we have two lines that are neither parallel nor perpendicular. Let's look at part D. In part D, our first equation is y equals negative 3 over 4x. So our first slope, m1, is negative 3 over 4. Our second equation is given in standard form, so let's switch it to slope-intercept form. Subtracting 12x from both sides gives us negative 9y equals negative 12x minus 15. Dividing both sides by negative 9 gives us y equals negative 12 over negative 9, x, minus 15 over negative 9. Simplifying gives us y equals positive 4/3 x plus 5/3. Now we know that the slope of our second line, m2, is equal to positive 4/3. Let's compare the two slopes. Our two slopes are opposites. One is positive and one is negative. They're also reciprocals. One of them is 3 over 4 and the other one has a 4 over 3. Since these two slopes are opposite reciprocals, these two lines are perpendicular. You have a few more examples to finish on your own, but this will conclude our video lecture.